before anyone has time to react. Good engineering does not pretend that risk disappears. It gives the system margins, feedback, inspection points, and simple habits that let people notice trouble early. When those layers line up, the result feels almost invisible. That is the quiet compliment infrastructure earns when it works. This is why MRI machines rewards patient attention. A design can be technically correct and still fail if it ignores how people move, wait, carry things, make mistakes, or rush. The best version of the system respects both physics and behavior. It gives force a path, gives people a cue, and gives operators a way to keep improving after the ribbon cutting is over. As you watch the footage, look for the small alignment choices, where motion begins, where people pause, where material changes direction, and where the system leaves room for correction. Radio waves. Radio pulses disturb the aligned atoms and let the scanner listen as they return to balance. Radio waves. Radio pulses disturb the aligned atoms and let the scanner listen as they return to balance. In magnetic resonance imaging engineering, the visible object is only the surface of the system. Under it are choices about field strength, signal-to-noise ratio, pulse timing, coil geometry, tissue contrast, patient motion, acoustic vibration, heat limits, implant safety, scan duration, and image resolution. Those choices are not decorative. They decide whether MRI machines feels calm, predictable, and useful when real people use it under pressure. One useful way to understand this chapter is to picture a patient being screened for metal before entering a room where the magnet is always on. That moment looks ordinary, but it is carrying timing, geometry, materials, controls, maintenance, and human expectation. The engineer is not trying to make one part impressive. The engineer is trying to make many small decisions agree with each other. The risk is that motion during the scan can turn useful data into a blurred image that has to be repeated. Good engineering does not pretend that risk disappears. It gives the system margins, feedback, inspection points, and simple habits that let people notice trouble early. When those layers line up, the result feels